Good day, dear colleagues. My name is Artur Zaporozhets. I am a senior researcher in the Institute of Engineering Thermophysics of National Academy of Science of Ukraine. Today I want to speak about energy informatics. The topic of my report is Information and Measurement Technologies for Solving Problems of Energy Informatics. The authors of this report and wallpaper you can see on the slide. As I told earlier, I will speak about modern science direction as energy informatics in context of using information measuring technologies. Solving the problems of energy informatics requires the use of information technologies in other areas. In particular, it's known that methods and means of measurement have always been, are, and will be the main tool for understanding the world. The resources of modern information technologies (IMT) are a significant component of information technologies in various areas of informatics, including energy informatics. This paper discusses the use of IMT resources for solving the problems of energy informatics, and the purpose of the work is the first, to form a system of statements which makes it possible to formulate the task of the IMT for solving the problems of energy informatics. And the second is to consider the potential resources of IMT for energy informatics. Energy informatics is an area of research that encompasses the use of information and communication technologies to solve energy use and management problems. The techniques used for smart implementations often combine IoT sensors with artificial intelligence and machine learning. Energy informatics is based on flow networks, which are the main suppliers and consumers of energy. Their effectiveness can be improved by collecting and analyzing information. This direction covers areas of application within A. Smart buildings by developing information communication technologies (ICT) to improve the energy efficiency of buildings. B. Smart cities by exploring the synergies between demand patterns and the availability of supply of energy flows in cities and towns to improve energy efficiency, increase the integration of renewable sources, and ensure resilience to systematic disruptions caused by extreme situations such as hurricanes and floods. C. Smart industries, including development ICT-focused solutions to improve energy efficiency and predictability in energy-intensive manufacturing processes without compromising process and product quality. And D. Smart energy networks, by developing ICT-centric solutions to coordinate supply and demand sustainable energy networks. On this slide, you can see a simplified scheme of the use of energy and information technology of the main research objects of this work. Also, based on the results of the analysis of a significant number of scientific, technical, and applied publications of Kubernetes, on Kybernetics, informatics, measurements, and other types of research, it was formed the following system of statements. You can see these 5 bullets on the slide. Next, a few words about methods and models of energy informatics. The capabilities and resources of modern science, technology, and production make it possible to implement the following research methods: scientific research, physical modeling, and experimental study. Physical and mathematical models are used in a wide range of research objects studies. Each of the models, physical and mathematical, complement each other, and in spite of the fact that they are copies and do not fully correspond to the real research objects, the models play a fundamental character in the research. Mostly a more formalized mathematical model is used. To perform the task of using information measurement technologies resources during solving problems of energy informatics. Three options for the formation of primary information are used: interaction and interconnection of research objects with the IMT sensor means. You can see this on the figure on the slide. Each study in the field of energy informatics ends with an assessment of the quality of the obtained results. The assessment procedure is very diverse, has a wide range of complexity, and is determined by the research objective. In one case, the result is an answer of the question yes or no, for example, a control problem. In the other, the result is used to justify the task of a new study. For example, to determine the dependence of the probability of signal detection under the influence of interference on the signal-to-noise ratio. The given example of a signal detection under the influence of interference is one of the complex problems of radiolocation, hydroacoustics, other branches of science and technology, and accordingly energy informatics, for the solution of which appropriate information support, hardware and software models of technical systems are used. The problem of signal detection under the influence of interference is important for a wide range of industries and is transformed into a number of independent tasks, the solution of which is based in solution of each is based on a specific signal interference situation. On this slide, you can see the conclusions of our report. They summarize information about statements above and the number of characteristics features of IMT that we will consider in the paper. So thank you for your attention, and my report is finished.